A wave has a wavelength of 24 centimeters. 2 points on the wave are pi/2 radians out of phase. The distance between these 2 points could be one of these 4 things. So what we're trying to do is, using this phase difference here, we're trying to work out a path difference. That's what this is asking us. The distance between these 2 points would be a path difference, using the wavelength of 24 centimeters. So if the phase difference is pi/2 radians, we can divide that by 2 pi, which gives us a quarter. So what that means is, if our phase difference is pi/2, our 2 waves are a quarter of an oscillation out of sync. And how that translates to path difference, so if our waves are a quarter of an oscillation out of sync, our path difference could be a quarter of a wavelength, it could be 1 1/4 of a wavelength, or 2 1/4, it could be any integer, 1,000 1/4 of a wavelength. The bit that matters is the quarter. That's what tells us how far out of sync these 2 waves would be. So what we can then do is, we can work out what each of these things would be until we get an answer which is one of these 4 options. So we'll start with 1/4 lambda. A quarter of a wavelength would be 6 centimeters, which is not one of our options. So 6 centimeters is a potential distance between the 2 points, but it's not one of our options, so we move on to the next one. 1 1/4 of 24 centimeters, that would be 30 centimeters, and that would be option C, which would therefore be our answer.